Alrighty, we now have our site pretty much finished for everything we need to do. We now have it hosted on a real IIS server on my local box. We'll get it set up on our production, quote-unquote, box shortly. But before we do that, we need to talk about the actual build process as well as the launcher process. We already did an overview a couple videos ago, so I'm not going to bust out Photoshop and do a bunch of diagrams. But we need basically two components. We need a script, some sort of piece of logic that describes the process of updating both the launcher, the servers, servers being the two Photon servers and the web server, and the client. We need a script that describes that logic so that it's automated, because if we don't have a script to express that logic, then it's not very automated. Then we need some sort of component to be able to invoke that script against our repository and perform certain actions. So those are really the two biggest pieces of the puzzle that are missing right now. Once we finish these two pieces of the puzzle, we can build our launcher, finally, our actual launcher that does all the things that it needs to do. Of course, the launcher is probably going to be the most trivial aspect of this entire exercise, surprisingly. Whereas the build scripts are going to be a little bit annoying to work through, but we will go ahead and get those set up in this video. So the goal of this video is to have a build script that can perform a variety of tasks. We need to be able to build out our solution, A. B, we need to be able to deploy our Photon servers as well as our website. And C, we need to be able to have our build script build a launcher and upload it to the website. And then finally, we need to have the build script build the client and upload it to the website. Now, building the client is actually going to be a little bit more involved because to build the client, we need to actually automate Unity, which actually is pretty easy to do. So the basic process of deploying the launcher and deploying the client is going to be build the project files, both in Visual Studio and in Unity, and then zip them up, and then publish them to an API endpoint. And we already have our API endpoint coded, so that's out of the way. Then once we finish the build script, all we have left to do is tie it into a continuous integration tool, and we are good to go to build our launcher. So what I'm going to do is I'm going to show you guys a very basic overview of the build system we are going to use, which is MSBuild. Now, there's a variety of build systems out there that you can choose from. A build system is nothing more than an ability to describe what are called tasks or targets, which those tasks or targets are simply responsible for executing a set piece of logic. So a build system is no more than a glorified task runner or a glorified console application that can execute particular tasks that are described to it via any sort of means. What I mean by that is there are build scripts or build systems such as Rake for Ruby, in which the Rake file or the file that describes the build processes is described in Ruby. There's psake, which is a build system that's described in PowerShell. There's an F# build system. I can't remember its name. I think it's called Fake. There's Ant and Nant, which are pretty old and crufty solutions for using an XML file to describe build logic, and so on and so on. The one we're going to use is MSBuild, and the reason why we're doing that is actually we've already been using MSBuild. Because MSBuild is what executes our projects. Have you ever wondered what these projects are? I mean, we see them sitting here in our Solution Explorer, but have you ever wondered what actually constitutes one of these projects? How does it work? Well, let's go ahead and take a look at that because that'll lead right into exactly what we're going to be doing in this video. I'm going to right-click one of these projects and hit one of these buttons here. Blah, 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 blah. Where are you? Open folder in File Explorer. And let's jump into source. So we see all of our projects. So immediately off the bat, we can say, okay, a project is just a folder. Well, that's actually wrong. Let's go ahead and jump into our data project and take a look at it. We have a variety of things. We have our binary artifact folder where our DLLs go, our object artifact folder where our intermediate build artifacts go. We have our namespaces such as entities, migrations, and services. We have this properties thing, which we'll talk about later. And then we have the actual meat of the project, which is going to be the project is simply defined as our csproj and our csproj.user. Now the csproj.user simply provides some user-specific configuration options for our project. We won't really talk about the csproj.user file because it's specific to a user, and we don't even deploy this or push this up into our repository. So in reality, this entire project right here, for example, MMO.data, is not a folder. It's not a collection of folders. It's not anything but this little file right here, our buzzmmo.data.csproj. What happens when we open it? Now, the buzzmmo.data.csproj is actually just a text file. And we can open it in any text editor, and I'm going to set my syntax highlighting to XML, and see that it is an XML file. This file is exactly what describes to Visual Studio what our project is, but it does more than that. As you see up here, we see references to MSBuild all over the place. First of all, we see up here our XML namespace is specified to be MSBuild/2003. That's because this XML file is an MSBuild file. It's an XML file that's formatted specifically to be understood by MSBuild, and MSBuild is the build system that comes with the .NET framework. So you can think of it as the official build system, even if it's valid to use additional build systems on top of it. But for simplicity's sake, we are going to be using MSBuild, because we already have MSBuild files written for pretty much all of our stuff. Because this file, what it does is it describes to MSBuild exactly the steps it needs to go through in order to compile the project into a binary. So you see it has things like referencing all of our CS files. You see that it has a reference for all of our other referenced assemblies. You see that it sets some properties up, and you'll notice something interesting. We have these configuration options, but you'll notice that they have a condition statement, which we'll be using the condition attribute in our MSBuild files as well. And the condition is an expression where MSBuild will either include or ignore this element based on whether or not this expression is true. So you see it specifies a bunch of these properties, it specifies a bunch of references, specifies a bunch of these include files, and so on and so on. Now fortunately, the MSBuild tasks that we are going to be creating are going to be very straightforward. They're just going to be executed in sequence, and they're not going to look like this. But I wanted to show you guys that if you open up a csproj, you will see an MSBuild file. So what's interesting about that is we can actually execute MSBuild directly on this file. Let's look at that. Let's go ahead and open our development tools command prompt. So this little guy right here, he'll show up in your start screen or your start menu as developer command prompt for Visual Studio and then the version number, in this case Visual Studio 2012. This command prompt is really cool in that basically what it does is it sets my path up so that I have references to MSBuild in the path itself in the context of this shell. Meaning, let's say I go ahead and navigate over to my C drive. Oh, come on. There we go. Okay, so if I navigate over my C drive and I type in MSBuild, look what I get. I get something like this. Now note that if I just typed in CMD and got a normal command prompt and I tried to type in MSBuild, I'll get MSBuild is not recognized. That's because, again, when you open up the developer command prompt, you get a bunch of stuff added to your path and a bunch of environment variables set up. So whenever you're doing stuff like executing an MSBuild script or something, opening up your developer command prompt will help you out, although we'll see that that's not necessarily needed down the road. But anyway, so we type in MSBuild and we hit enter. MSBuild is a program, msbuild.exe, and is located, it's actually located physically on your computer under your Windows folder, System32, Microsoft.NET, right here, Framework or Framework 64, the version number of the .NET framework you want to look at, so in this case 4.0. Remember, 4.0, this folder also contains 4.5 because 4.5 was an in-place upgrade to 4.0. Then we come in here and we can see MSBuild sitting right there, msbuild.exe. Some other fun stuff you can find in this folder. CSC, the C# compiler. You should also be able to find the Visual Basic.NET compiler as well. But the point is, this folder contains all these tools. MSBuild is a tool that comes prepackaged with .NET Framework. Really nice to use as a build tool, since any system with the .NET Framework installed will have it installed. So that is also a really good property of it. Anyway, so now we know we can execute MSBuild, but when we execute it, we notice that it says something like specify a project or solution file. The current working directory does not contain a project or solution file. So let's go ahead and do that. I'm going to hop back over into into my File Explorer, and I'm going to copy the path to my buzzmmo.data file. So I'm going to type in cd, and then I'm going to put in quotes, and then I'm going to paste the path, hit enter. Of course, I have to switch over to the F drive because that's where I have the project. And you'll notice that we are now in the folder that contains the buzzmmo.data.cs proj. So what happens if we type in msbuild buzzmmo.data.cs proj? We hit enter, and we see some output that actually should look a little familiar, because some of this output is also repeated in Visual Studio. In fact, when Visual Studio compiles your project, it executes MSBuild on the CSproj or the SLN file. And the SLN file is just a collection of CSproj files, and CSproj files are just MSBuild files. So we can see that we can actually build it from the command prompt simply by typing in msbuild and then a CSproj. Now this is useful because what we want to do is we want to create a custom MSBuild file that describes a variety of tasks that can be performed so that we can automate these processes. And then so we can just plug this entire solution into a CI tool. The CI tool will execute MSBuild against our build script, and magic will happen. So let's look at how to do that. What I'm going to do is, let's see, I'm going to go ahead and create a new solution folder. So up here on solution, I'm going to click on this. I'm going to right click on the solution itself. I'm going to say add, and I'm going to say new solution folder. The interesting thing about a solution folder is it doesn't represent a physical folder on your hard drive. It's just, you can think of it as a virtual folder. And I'm going to call it build. Now inside of build, I do need to create my MSBuild file. And that's what I'm going to do. I'm going to right click build. I'm going to say add new item. I don't want a new project. I'm creating a new item that lives outside of all these projects. And it's going to ask me what I want it to be. And what I want it to be is I want it to be called buzzmmo.build.proj and hit add. Now, a .proj file, .proj file, is a file recognized by Visual Studio as an MSBuild file, meaning that we will get, syntax highlighting and all that fun stuff. It'll assume that it's an XML file and give us the ability to do a variety of cool things. Okay, so now what we have to do is let's go ahead and build our first task. Let's say that we wanted to write a script that automatically built out, let's say, our entire solution. Let's say we want to be able to type in msbuild buzzmmo.build.proj space target equals blah, right? So remember, a target is a task. You can think of a target as a method. So how do we describe that? Well, first, we'll go ahead and we'll have to describe our project. So I'm going to open up an XML element, and this is going to be the root element. And you'll notice that Visual Studio helpfully included project right there, because Visual Studio recognizes .proj as an MSBuild file, and it'll give us some nice autocomplete. Let's go ahead and hit enter. Now in our project, what do we want to do? Let's go ahead and say our tools version is 4.0. And then let's go ahead and let's not give it a default target. I'm not sure if you can not give it a default target. So we're going to go on an adventure here. And then I'll close that element. Now it doesn't seem like we're getting any syntax highlighting, so let's go ahead and close that file and reopen it. By closing and reopening it, Visual Studio got its act together and decided to actually colorize our tokens. So now we have code completion, which is good, or syntax highlighting, which is good. Okay, so like I said, let's see if we can get away with not specifying the default targets. Let's go ahead and define a target. So remember, a target is like a method. It's like a little pre-packaged nugget of logic that we can automatically execute through a tool that understands this particular build system. So let's create a target. And what's a target? A target is, first of all, it's an element, but it also needs a couple other parameters. We can provide things like a name, we can provide after targets, before targets, we can apply a condition. We can actually apply this condition on pretty much any element we put into it. But in this case, let's go ahead and do name, and let's say our name, let's give it a name. Name is good. This is going to be the project or the target that is responsible for building our entire solution. Because I want to pre-build the solution based off of a particular build configuration, and that's the first thing that I want to do or have happen when things execute. So we're just going to call this target build, because I think build is a good, or let's just call it build solution. That's a little bit more explicit right there. We can call it whatever we want, but I think build solution works out pretty good. Then let's go ahead and execute our solution. Let's go ahead and actually build our solution and cause the same behavior that would be caused if I hit F6 right here. So that everything is built out, all the DLLs are built, they're placed, everything is happy. So let's go ahead and execute something. So the way that targets are defined is going to be line by line. So let's say this is command 1, and then let's say this is command 2. These commands will be executed in order. So let's start with our first command. Our first command is going to be a reference to MSBuild. Now, MSBuild is called a task. You can see a variety of different tasks available to us. We have things like ASP.NET compiler, convert to absolute path, we have copy, we have CSC, which is the C# compiler, delete for deleting files, error out, displaying an error message, exec is a very powerful one. Exec allows us to execute an arbitrary command, just like you would do if you were typing into a console window. But the task that we want is MSBuild. And that's because we want to have this MSBuild project actually execute a sub-MSBuild project in order to perform the compilation of our project. So the MSBuild project is going to require that we specify projects. And projects is just going to be a list of projects to build. So projects, what we want to do is specify our SLIN, or solution file. However, in order to specify our solution file, we need to know which directory that this build project file is considered to be inside of, because we need to execute a relative path. I don't want to put an absolute path that's only valid on my machine into this project's parameter. So let's jump back into Explorer and let's see where our build project ended up on. And you'll notice that it ended up right here at the root of our solution. BuzzMMO build.proj. This might be a little confusing to you because you saw us earlier right-click this build folder and stuff this proj file in it, but that's because this build folder is a virtual folder and doesn't actually exist on the hard drive. So when we create a new solution file, what we end up with is that solution file being placed within the root of our solution, which means that's where we're going to be executing our MSBuild from. And that means that we can go ahead and specify paths relative to that folder for dealing with files and folders. Which means MSBuild projects. What's the project's attribute going to be? It's simply going to be buzzmmo.sln. Okay, so let's see where this gets us. Before we go and flesh out our MSBuild, because we're going to have to do some more fun stuff with this. Obviously, this isn't a very interesting build script because you can do the same thing by just typing in MSBuild buzzmmo.sln. So let's go ahead and see what this gives us, and then we'll move on with our MSBuild. So I'm going to go ahead and I'm going to fire up my developer command prompt. I'm going to jump into my folder. I'm going to switch over to that drive, clear out the screen, and let's type in MSBuild space buzzmmo build.proj. Now if we hit enter, you'll see something. You will see that I forgot to specify my XMLNS. Now the XMLNS is the namespace for this XML file, and that is going to be required. So let's jump on our root element, our project element, come up here and type in XMLNS. I should probably realize this was required because of that little icon right there. And what we're going to do is we're going to type in http://schemas.microsoft.com/developer/MSBuild/2003, which that is the XML namespace for this element. Coming back into our command prompt and typing in MSBuild buzzmo.build.proj again, we hit enter, and we see that we were actually able to perform the compilation. So you'll notice that we have our build started. You'll notice we do our default targets. So our build solution was determined to be the default target for this file, probably because it was the only one. But you'll notice a couple other interesting things. First of all, you'll notice this. Well, let's go ahead and look at this right here first. This is more important. The reason I say this is more important is this is exactly where execution jumps from my .proj file into the proj file that I specified, or into the slin. The next important thing with this is this: building solution configuration debug any CPU. Now, that's actually not really what we want all the time, because when we deploy this to our production box, we want to be able to have it build out release versions instead of debug versions. The only time we really want to do debug versions is when we're doing local development on our computer. So we need to find a way to set the solution configuration to a value other than debug any CPU. But that leaves us with a bunch of questions, like, for example, where does that value come from, and how do we pass it into the MSBuild task? Well, let's enter the second one first. The way to pass it into the MSBuild task is pretty straightforward. All we have to do is say properties, equals, and then we can say, how about, we'll say release any CPU. Or sorry, derp. Configuration equals release any CPU. Properties, you'll notice, is a plural name, which means you can pass more than one properties into this attribute. Configuration is one of these properties you can pass into. There's quite a few other ones, and the configuration that we're setting it to is release any CPU. Make sure to save that file, come back to our developer command prompt, and execute this again and see what we get. We get an error. And that's because our release any CPU. Oh, derp, derp, derp. We don't specify the any CPU, that is implied. Because the configuration is release, and then the architecture is any CPU. To change the architecture, you would have to pass in a different property. As you can tell, MSBuild does even sometimes confuse me. Actually, it confuses me all the time. It's a very finicky build system, but in actual fact, old build systems are pretty finicky because they want you to do things in very particular ways. But the best way to go about working with this is to just try something, save it out, and then execute the build file. So we're going to be doing a lot of that. So let's go ahead and execute the build file again. And what do we get? We get a full compilation, but more importantly, we don't just get a full compilation. We get a release compilation. As you'll see, bin release. So it's actually placing all the artifacts into the release folders instead of the debug folders, which is exactly the behavior that we wanted. So not only did this build in release mode, but this also set up everything like turned off optimizations and all that, or turned on optimizations and all that fun stuff. Okay, so like I said, we answered the first question. How do we specify which configuration we want to build the solution in is now specified. But now, how do we change this? Not surprisingly, the way we change this is with variables. So let's go ahead and create some variables. I'm first going to show a way to create variables unconditionally, and then we'll talk about conditional variables. So what I'm going to do is I'm going to create a property group. Now, a property group is going to allow me to define variables that I can reuse throughout this build script. So the way we do that is I'm going to say build config release. So the format that we want to specify our properties in is the element name is going to be the variable that we want to specify, and the innards of that element, the inner content, is going to be the value that that variable is going to be set to. So now that we've created a variable, let's go ahead and use it somewhere. So in this case, we have configuration equals release. Well, how do we change release? How do we replace that with our build config variable? Well, we do that with the $ syntax. So $ and then wrap with parens, and we can do build config. Notice that we even get code completion here. If you just take $ and wrap in empty parens and hit control space, you'll actually be able to see a list of a bunch of these different already defined properties that we can use. So that's really cool. But let's go ahead and use our build config. So now our build config is being specified by a variable. Coming back into our development console, hit enter. We'll see we get the exact same behavior, and you'll notice that this is still going to be in release mode. We can verify that. You'll always want to, whenever you do something like this, like abstract a configuration out into a variable, make sure that things are still working the way you would expect them to. But in this case, they are, because we are indeed building this against release any CPU. Okay, so we've done that, but now how do we differentiate between a debug build and a release build? You might be asking yourself, why would we want to do that? Well, there's two answers to that question. First of all, we need some sort of way to test our build script. Second of all, we need to be able, so that means that we have to be able to perform these builds on our local machine and not just on our production build server. In addition, we also want to be able to use variables for just good practice, so that if things change down the road, it'll be very trivial to change your build config, for example. So basically, I want this entire script to be executed in one of two ways. Either it's in development mode or it's in production mode. So I only want to specify one variable, prod or dev, which I'll pass into the env variable, which I'll leave as undefined. And what I want to do is I want the behavior of the script to depend on whether it's in development or production mode. So basically, if you think about it in a high level, the goal of this script is to choose between development environment and production environment, and then do different things based off of that. Adding in additional environments such as staging or QA would be trivial at this point. So let's see how to go about doing that. The first thing I want to do is I want to specify a property group all the way at the top. Note that you don't need to specify a new property group for every variable that you want to define, but as you'll see very shortly, it is advantageous in this case to define two property groups. So what I'm going to do is I'm going to say env prod. So I want to default to prod, or actually no, let's default to dev. But I'm going to do something interesting here. Oh, auto completed that for me. But I'm just going to type this in longhand. So condition equals, and then what I want to do is I want to say quote env space equals empty. So what I'm doing here is I'm saying property group, I'm declaring a new property group, then I'm saying set the env variable to dev, but only if the env variable is blank. And you might be saying, well, you haven't actually set the env variable anywhere in the script. Obviously, it's going to be blank, therefore it's always going to be dev. Well, when we execute this script, when we actually run it, we can specify overriding properties. So we can specify the end from the command prompt, which is what we're going to do to differentiate ourselves from the development and the production environments. So now that we have our env variable set up, we can now do things based off of it. Let's go ahead and fix up this property group and create a new property group. So I'm going to say this property group is going to have a condition of quotes env equals quote prod. That means that this block will only execute if the env variable equals the string literal prod, which prod is short for production. Now let's create a corresponding property group. So I'm going to say property group. Inside this property group's attributes, I'm going to supply a condition. And not surprisingly, the condition is going to be if the variable env equals dev. So if the variable env equals dev, we'll execute this property group. And then we're going to say build config equals debug. So what we've effectively done is we've factored out the choice of building the solution as either a development or a production build, or a debug or release build. We factored that out into a tertiary variable, our env variable. And our n variable will be used to specify more than just the build config. We'll specify quite a few different properties in these blocks. So hopefully it's becoming clear why we're doing this, because now we can specify a bunch of variables if we're in development mode, and we can specify a bunch of variables if we're in production mode. And then we can simply depend on these variables throughout our script, and we will have a build script that supports both production and development. So let's go ahead and test that our variables are working. I'm going to come back in here to my developer command prompt, and I'm going to type in MSBuild buzz MMO build.proj. Then I'm going to hit enter, and let's see what we get. We get a debug build. We can tell that it's a debug build one of two ways. First, we can see the build artifacts are being copied into the debug folder. Second of all, we can scroll all the way to the top, and up here at the top, we will see that it says Building Solution Configuration Debug Any CPU. Okay, let's do this again, but let's specify /p : let's say env equals dev. And we get a something build. Let's see if I can spot the word debug or release anywhere in here. There we go. We do indeed get a debug build. And that's because we've overridden the env variable to equal dev by specifying a /p : env equals dev. Now, let's try env equals prod. What do we get? We get a release build. We can see it's a release build because it is copying the build artifacts to the release folder. Now let's go ahead and just do something fun. I don't know what's going to happen, but let's say env equals bleh, something that isn't either dev or prod. And we get an error, and that's actually really cool because now, because the way we wrote the script, if we specify an invalid environment, we will get an error. Now the error isn't immediately obvious because you'll see error, the specified solution configuration blank any CPU is invalid. But you know what, that's fine. Any error is a good error here. And we can just remember if we see an error like this, we might have not typed in dev or prod into our env variable. Alrighty, let's go ahead and stub out our other tasks. So we have our build solution task. Let's go ahead and stub out our other tasks and talk about how we can specify which task we want to execute when we invoke MSBuild. So the other tasks that we want, so we have our build solution, which builds our entire solution. We will definitely want our target name equals, sorry, these are targets, not tasks. Target name equals deploy Photon. Now, this is interesting here. So our deploy Photon file, what that's going to do is we're basically going to say copy Photon servers to proper folders is what we're going to be doing here, right? But, why is that? That bugs me. There we go. But we should only do a deploy Photon if we've done a build solution. So how do we specify that? Well, we simply say depends on targets and then type in build solution. So target name equals deploy Photon depends on targets build solution. Now let's go ahead and I'm just going to say warning. What I'm doing here is don't type this in. I'm just going to have it invoke a warning right here, and the reason I'm doing that is so that I can know when the deploy Photon target was hit. So now let's come back in here to the developer command prompt and talk about how we can invoke either of these things. Now I haven't specified a default target, and I can't honestly remember what the behavior of MSBuild is if you don't specify one. So let's go ahead and take our MSBuild buzz MMO build.proj and just hit enter and see what we get. Okay, so you'll see that what it's going to do is if you don't specify a target, it is simply going to execute the first target in the file. So that's fine. So now let's go ahead and specify a target. So what I'm going to do is I'm going to say MSBuild buzz MMO build.proj /t : deploy Photon and hit enter. What do we get? Well, we get exactly what we did before by typing in build solution, but we also get this awesome warning right here. hit deploy Photon. Of course, that warning is just something I put in the code to show us when we hit this target. So you'll notice the syntax for specifying our target is going to be /t:, and then the target name. We could also do this specifically by typing in build solution as the target name, but since build solution is the default target, because we didn't specify our default, so our default must have a default. In that case, the default is the first target, which is build solution. But if we specify deploy Photon, we get both, because deploy Photon depends on build solution. So we can ensure that when we hit the deploy Photon target, we will have the solution built in either release or debug mode, depending on our environment. Okay, so I'm going to go ahead and clear out this warning here, and then I'm going to create another target. So again, I'm just stubbing out targets so we know where exactly we're going with this. They will all depend on build solution, by the way. The name of our second target is, let's say, deploy website. And then after we deploy the website, we will execute web deploy to actually deploy that website to the proper location. Actually, we'll not only just execute web deploy, we will build deploy package and then execute web deploy. Next up, let's create another target. So we have deploy Photon and deploy websites, but we also need deploy launcher, which depends on target build solution. Now, what's deploy launcher going to do? Well, it's going to zip launcher, upload launcher. Now, the zipping and upload are things that we're going to actually have to import new tasks into. And we'll see how to do that shortly. The last target we need is target name equals deploy client, which will depend on target build solution. Deploy client will build standalone Unity build, zip Unity build, upload zip. All right, so those are our 4 big targets that we need to implement. And we need to make sure that they'll work for both the production environment as well as our development environment. So let's go ahead and work on our deploy Photon. Deploy Photon is going to be pretty straightforward. Well, no, it's not going to be straightforward, because in that case, we're going to have to talk a little bit about MSDeploy. In fact, all of these things, except for deploying our client or deploying our launcher, will require MSDeploy. So, yeah, I think I'll go ahead and cut the video here so that we can talk about getting MSDeploy set up. Well, we'll talk about getting MSDeploy set up later. What we'll do is in the next video, get our deploy launcher and deploy client working, because those are going to be a little bit non-trivial. Alright guys, we'll see you in the next video.